going to talk about the topic of the hand.
In this modern day and age, we use our hands for many things. We use it for gripping, for pushing, for throwing, and we use it to communicate. Yep, language is not just spoken and heard. We can see it in writing. We can feel braille with touch. We can understand each other through hand gestures. So we say that language is modality independent. This means that language exists in various forms. We can understand each other, not just through speech, but also in writing and other forms of media.
Yes, you can see it and read it. You don't just write, we draw stuff and we use hand gestures as well. We have gestures such as thumbs up and V sign. The sign language that we are most familiar with will be the one that is associated with the deaf community. Different communities in different countries have came up with their own version of sign language that has its own grammar and linguistic structure, which is different from those of spoken or written language. So we see that the human hand can be used to communicate in many intricate and interesting ways. But was the human hand evolved to communicate? To evaluate if the evolution of the hand was related to communication, we look into the evolutionary history of the hand and relate it to the origins of human communication and language. However, this is so difficult to do because until now, no one really knows how it all came about and there is so little evidence pertaining to this topic. All we have are theories that no one can confirm. In this video, we'll attempt to do this by tracing the origins of language back to our primate ancestors and review its relation to evolutionary adaptations, specifically of the hand. Let us now look at the evolutionary history of the hand and what are the main adaptations of the hand targeted at throughout human history.
The human hand is such a complex structure. In fact, it has the most complicated system of bones and joints in the human skeleton. There are so many adaptations that it is highly doubtful that it evolved solely for communication. Early humans may not have possessed the ability to grip and use tools as we modern humans can. Let's take a look at the difference between a fossilized hand and a modern human hand. Notice that humans have approximately 20 forearm muscles, while primates have between 18 to 19. As for the hand muscles, we usually have 21 muscles, while primates have more than 30. Unsurprisingly, none of these muscle bundles are unique to humans. In fact, all of these muscle bundles are, you guessed it, they are shared with primates as well. Does this provide evidence of a shared early ancestry? Maybe, nobody knows. In any case, we can be certain that these evolutionary adaptations has enabled us to grasp and use tools. Let's take a look. If we compare the anterior view of the human hand with the anterior view of the chimpanzee's hand, we can see that the part highlighted in red is actually the crucial muscle associated with that particular hand. For the chimpanzee hand, we can see that the muscle leads to the central of the palm as opposed to that of the human hand, in which case the crucial muscle leads to the thumb. The difference suggests that humans may have stronger thumb flexibility and thumb flexion power as opposed to that of the chimpanzee.
Similarly, if we look at the posterior view of the chimpanzee's arm and compare it to the posterior view of the human arm, it is evident that the human arm does not have the dorsal-epithoklaris as well as the epithoklaris muscles that are found in the chimp's arm. Furthermore, the presence of the extensor pollicis brevis muscle found in the thumb of a human arm suggests better motor control of the thumb that is not found in chimps.
When it comes to relating these adaptations to the origins of language, fossil records have shown that a modern hand capable of sign language soon evolved after our prehistoric ancestors stopped walking on their knuckles, and we believe that using our hands to gesticulate could have been the oldest form of communication. This form of communication would have been useful in the past during hunting trips, where groups of men would slowly sneak up on their prey and communicate through visual signals to avoid alerting the animal. Our ancestors also used language to communicate to each other in cooperative activities such as foraging. To find the things we need in our natural environment, we need visually guided control over fine motor manipulation. The capacity for fine motor control indicates a readiness to use a complex system of gestures. It is possible that the capacity to communicate relates to one's survivability and reproductive ability, as good communication improves efficiency when finding food and also at critical moments where one is pressed to survive. Good communication is also relatable to productive ability as it probably increased the chance for reproduction. Thus, the good communicative ability, along with this readiness to use a complex sign language system, is passed to the next generation through natural selection.
So did the hen evolve to facilitate communication? Maybe, no one really knows. It was probably our ancestors who could communicate better, who ended up surviving and procreating the next generations to evolve themselves into who we are today.
As research suggests, the hen was mainly evolved for gripping, throwing, and clubbing. It was probably a combination of these factors that evolved the hen into what it is today. Our ancestors probably found intelligent ways to leverage on these adaptations to communicate, passing down these amazing cognitive ability to the future generations, the people of the